Hi, friends. I hope you have been having fun learning all about serverless today. Do you want to have complete control over what gets deployed on your Kubernetes cluster? Do you have existing deployment certification processes that you want to extend to Kubernetes as well? By creating custom admission webhooks for Kubernetes, we can define strict regulations to exclusively deploy approved resources on our cluster. My name is Rahul, and in this short video, we'll learn how to create serverless admission webhooks using Azure Functions to accept or deny application deployment requests. Azure Functions also has built-in output bindings for Twilio, which is quite cool. Today, through our sample application, we'll not only control the deployments, but also use Twilio to post updates on the status of the deployment through text messages. Before we proceed with the demo, let's take a few minutes to understand how your API requests made through the Kubernetes CLI, which is kubectl, makes their way through the Kubernetes API server. Every API request to Kubernetes is first authenticated and authorized. There are several types of authorization modules available in Kubernetes. For example, attribute-based access control allows authorization rules to be configured via local files, and role-based access control that allow authorization rules to be configured via the Kubernetes API. An authorized request then moves on to a special class of admission controllers called the mutating admission controller. A mutating admission controller can modify the object that they admit. If you have used any sidecar-based service mesh, such as Istio, then mutating admission controllers are what inject a sidecar to your application workloads. The admission controllers are of two types, standard and dynamic. Standard admission controllers are packaged with Kubernetes release as plugins. On the other hand, dynamic controllers are configurable at runtime and are developed outside the core Kubernetes code base. The only type of dynamic admission control is admission webhooks, which receives admission requests via HTTP callbacks. Here you can see how the admission controller sends an admission review HTTP request to the dynamic admission webhook and receives an admission response. After the mutation, if the request moves on to the schema validation controller, which checks whether the request conforms to the Kubernetes API specs. Next, the request progresses along to the validation admission stage, which, just like the mutating admission controller, relies on webhooks to dynamically validate the request. You can see that the validation admission controller issues a similar request and expects a similar response. Since we will soon build a dynamic validation webhook ourselves, we'll not discuss it in detail right now. Once the request has moved across the API server's controllers, it is saved in the etcd key value store. etcd has several listeners attached to it that get notified on changes. These listeners use the state information present in etcd to modify the actual state of the cluster. Let me show you a static admission controller in action. Kubernetes ships with an admission controller named namespace exists, which checks whether a namespace already exists. So, if you try to create a resource in a namespace that doesn't already exist, it will simply fail the request. Here, I'm demonstrating a simple kubectl request that is trying to create a deployment in a namespace that doesn't already exist in my cluster. If you execute this request, you would see that the server would return an error. This error has been propagated back to our CLI through an admission webhook. We will now walk through the steps of operationalizing a custom validation webhook. You will first need to have access to a running Kubernetes cluster on the cloud, such as GKE for Google, AKS for Azure, or EKS for AWS. Or you can use the local cluster setup, such as Docker Desktop that I'm using, Minikube, or Kind. After you have provisioned your cluster somewhere, we'll design and build a validating admission webhook. We are going to implement our validating admission webhook with .NET Core and deploy it to Azure Functions. Do you remember that a dynamic admission controller sends an admission review request and expects an admission response from the webhook? The specification on the right is the schema of the request that the configured webhook would receive. On the left is the response that the webhook needs to return to the controller. The request specifies the operation that you are trying to perform, such as creating a resource or updating a resource. And it also contains the Kubernetes specification file that you're trying to apply as well. Whether the request is approved or denied depends on the value of the property allowed in the response. If the value of the property is set to true, the request is approved, else it is rejected. Let us now discuss the overall design of our system. A developer writes the specification for the deployment that they want to apply to the Kubernetes cluster. A custom dynamic validating admission controller will receive the request and send it to our Azure function for approval. Note that the function has a maximum of 30 seconds to decide whether the request should be approved or denied. In either case, the response is returned to the API server and ultimately to the developer's console. During the processing of the request, Azure Function also uses the Twilio output binding to communicate the response to a phone belonging to operations or SRE via a text message. Please download the source code of the application from the link shown in this slide's footer and open the repo in your editor. Next, I will guide you through the repo structure and deploy the function app to Azure. Let's now discuss the structure of our repo. Once you expand the repo, you would find that it contains 3 folders. The first folder, named function, contains the source code of the validating webhook Azure function that will deploy to Azure. The second folder, named infra, contains a simple script that you can execute to provision an Azure function in your subscription. The third folder, named specification, contains 2 specifications. One of the specifications will be used for provisioning a validating admission webhook that will be used to connect the Azure function with the Kubernetes admission controller. Another specification called the Alpine spec is there to test our admission controller and the webhook. Let's now go through the source code of our Azure function. Open the function folder in a separate VS Code instance and go to the admission control fx file. Let's now read the source code together. So in the beginning, you will see that there are 3 constant strings defined, which are just the templates for the text messages that we would dispatch through Twilio. Next comes the actual definition of the function. This function has a name called admission control fx. Then comes the actual body of the function. Since it's an HTTP triggered function, that's why we decorated it with an HTTP trigger attribute. Due to this attribute, when we receive an HTTP request, the request object would be pre-populated. Remember that we also want to use Twilio to dispatch SMS to an SRE or an operations person. So we will use the inbuilt Twilio SMS attribute that takes as input the configuration settings that specify the account SID and the auth token supplied by Twilio. You will notice that there is a phone number in the attribute as well. This phone number is provisioned by Twilio. So whenever you receive a text message, it would be from this number. In order to send a message, all you need to do is add an SMS object to the iCollector instance. Let's proceed further. So this line of code will read the request and convert the request object to string. Next, we will deserialize the JSON object to an Expando object and extract the operation from the object. This operation would either be create or update to specify whether we want to create a new deployment or update an existing deployment. Next, from one of the labels of the specification that we'll see next, we'll read the name of the application. To demonstrate that you can apply custom rules in your Azure functions to accept or reject a deployment, a rule that I've configured here is to reject a deployment if the replication count or the count of replicas of a deployment is less than 3. So this particular assignment would read the number of replicas requested for an object. And if the replica count is less than 3, then we prepare an appropriate SMS message. will use the Twilio binding SMS, the Twilio binding to dispatch an SMS using the send SMS function, which we'll see next. Finally, the method would return an OK object result, but with the approved the property of the value of the approved property set to false, which will ultimately decline the deployment request. This set of statements extract the containers that make up the deployment. The next statement just combines the names of the containers that make up the deployment in a CSV. Now, if the operation is create, that is, if we want to create a new deployment, then it will prepare an appropriate SMS message. Else, if we are requesting an update of a deployment, it will peek into the existing deployment object and try to find out the images that made up the previous deployment. It does the same operation as it did previously. It would just convert those image names into a CSV. It will use these two pieces of information to compose an SMS message. Finally, the send SMS message is used to dispatch an SMS to the SRE or ops person to notify them whether an update or create operation was issued by the developer. In both the cases, that is, create or update, we return an OK response back to the controller with the value of the attribute approved set to true, which means that the deployment would be accepted by the validation controller. The send SMS is an internal method. Here you can see that all this method does is it fetches the phone number from an environment setting, and then it uses the message that was it uses the string message that was composed by the function and simply adds that message to the Twilio collector. Now that our application is ready, I will now deploy it to Azure Function. In order to do that, I'll use an extension from Azure for VS Code. So once you have installed that extension, you would see that it will populate any Azure functions that you have in your subscription. So all you need to do now is right-click and select Deploy to Function App. On selecting that option, it will open a pop-up to ask for your confirmation. Once you click on Deploy, it will initiate the process of deploying your application. While that operation goes on, I will show you another thing. So remember that Twilio requires a set of configurations or settings in order to work. Once you save all those configurations in a file called local.settings.json. This file is not checked into the source control. However, you can deploy this file to your function by right-clicking on the application setting and selecting Upload Local Settings. What it would do is it would simply pick the settings and apply it to your Azure function so that you don't have to manually go to the Azure portal and upload those settings yourself. So once those settings have been deployed, let's move on to the Azure portal. And here you would be able to see all the settings that have been deployed. You can also go to the Functions tab, and you would see your function sitting here, and it is now ready to accept requests. Now that our function app is up and running, it's time to configure the Kubernetes cluster to use it. We'll define a validating webhook configuration and submit it to the Kubernetes API. The configuration specifies the URL that the validating admission controller should send the verification request to, and specify the conditions on which the webhook should be invoked. The specification you see on the screen specifies the URL of the function app we just deployed. All webhooks are required to use an HTTPS endpoint. The CA bundle property contains the base64 encoding of a PIM formatted root certificate used by the webhook. Since I have not used any custom TLS certificate on my function app, I simply encoded the Azure's default certificate for any function app. Let's look at the rules now, which specify the conditions on which the webhook will be triggered. The rule condition shown in this specification will evaluate to true if we issue a request to create or update a deployment. The scope property value namespace means that any deployments in the default namespace would trigger this webhook. The timeout seconds property in the specification specifies the timeout period in seconds for which the API server will wait for a response from our function. The property failure policy instructs the admission controller to fail the request if the function times out or returns an error. The side effects property set to none means that calling this webhook won't change any resources in the cluster. Finally, the property admission review version specifies the version of admission review request it can process, which can either be v1 request or v1 beta 1 request, which is the same as the version of the configuration, and one older compatible version of the same configuration. Let's now deploy this configuration to our cluster. In order to deploy our validating webhook configuration, switch to VS Code and open the folder named specifications. Within specifications, open the file named validating webhook YAML, which contains the specification for our validating webhook configuration. Let's now read this specification together. So you will see that this specification or the name of this validating webhook configuration is compliance. Internally, we have named the webhook compliance.custom.azure.co, and the URL of the webhook is set to the URL of the Azure function that we just deployed. Once you're trying this out yourself, please take care to change this name to the function that you deployed. As I said that I haven't applied any custom certificate on my Azure function. So in the CA bundle property, you will see that the string here is just base64 representation of the PEM certificate for the domain star.azurewebsites.net. Finally, the rules section evaluates to true whenever an update or create deployment command is issued. The other properties are the same as what we saw in the specification in the slide, which specify a timeout, a failure policy, side effect, and the version. In order to apply this specification, let's launch the terminal and type the command kubectl apply -f and the name of the file. Once the webhook is configured, you would find that you would find a success message returned from Kubernetes. It's now time to test this implementation, and which is what we will do next. In order to test our validating webhook, I have created a test specification available in the specifications folder by the name alpinespec.yaml. Open this file and we'll go through the specification declared in it next. So let me switch to the presentation mode. Before we read through the spec, let's check what is the status of our of the validating webhook controller that we provisioned before. So in order to do that, just launch your terminal and issue this command kubectl get validating webhook configuration. So hit enter, you would see that the compliance webhook that we provisioned a couple of minutes ago is sitting over there, which means that it is up and running. So let's head back to the specification. Here you can see that the first thing that we do is create a namespace. The next thing that we do is create a deployment with the name Alpine deploy. You might remember that one of the validation rules that we configured in the webhook was to reject a deployment if the replica count is less than 3. In the spec, you can see that I have deliberately set the replica count to 2, which means that this deployment shouldn't be accepted by Kubernetes. So let's test this deployment now. And in order to do that, let's switch back to the terminal and apply this specification. And here you will see that that Kubernetes accepted the namespace creation request, but it declined the creation of a deployment because of the reason that we just spoke about. And this is the message that was returned by the Azure function. I can hear that my phone received an SMS. So let's now jump on to see what is the SMS that I received. So let's switch to the Your SMS app that I have on my phone. And you would see that I received an SMS from the number that we configured in Twilio, which says that the deployment of the application has been blocked because it didn't meet the appropriate replication count, which is nice. So let's now fix this issue. Let's increase the count of the replica to 3. And let's apply this specification again. We'll see that this time the deployment did succeed. And I can hear that I received an SMS as well. So let's head back to the app. And you would see that the SMS this time says that that a new application was provisioned on the cluster. All right, so let's now try to update this application. In order to do that, let's head back to the specification. Let's try to change the name of the image to, let's say, 3.9.1. Let's save the specification. Again, go to the terminal and apply the specification once again. See that this time the namespace wasn't changed, but the deployment has been updated. I'm still waiting for an SMS to arrive from Azure Function though. Okay, so the message took some time to arrive, but it did arrive after some time. And you can see that this message says that the deployment was updated from Alpine Image 3 to Alpine Image 3.9.1. So this covers all of the cases that I had to present. So let's head back over and conclude the presentation. Finally, here are the links to all the resources and all the concepts that we spoke about in this presentation. Now, one of the concepts that we have ignored in this discussion is security. We currently have no measures to ensure that requests to the webhook are coming from the Kubernetes cluster. As a result, malicious users could spoof requests to our function app and charge our subscription for its usage. To address this, let's look at some steps we can take to secure our function. One of the measures that you might want to take is to apply inbound IP restrictions on Azure Function so that it only accepts traffic from an allowed range of IP addresses. Second, you can use an object named admission configuration to add security tokens and allow functions to only accept authenticated requests. This brings me to the end of the presentation. I hope you had fun learning all about controlling admission to your Kubernetes cluster with Azure Functions. I look forward to continuing this conversation with you on my blog, thecloudblog.net, or on Twitter @RahulRai_N. Thank you.